Hey everyone, and welcome to this explainer. Today, we're unpacking a truly fascinating textbook chapter on the origins of chemistry and metallurgy in ancient India. We're going to explore a side of scientific history that often gets completely left out of the standard curriculum. We'll be revealing how ancient civilizations mastered incredibly complex chemical processes thousands of years ago. It's a real game changer for how we view the history of science. Here's our roadmap for today. We'll be hitting 5 key stops, starting with the origins of chemistry, then moving to Indus Valley chemical innovations, the first atomic theory, ancient Indian nanomedicine, and finally, wrapping up with ancient wisdom, modern science. Let's dive right in. All right, Section 1, the origins of chemistry, from alchemy to early science. So, what do you think? Where did modern chemistry actually begin? Well, the answer you get really depends on where you look. Most standard textbooks tell us it evolved as a formal science somewhere between 1300 and 1600 CE over in Europe. But if we dig a little deeper into our source material, we find that the real roots of chemical manipulation stretch much, much further back in time. Now, what's wild is that the earliest chemistry in Egypt and Europe was largely driven by a quest for, magic, immortality, and wealth. You had alchemy and iatrochemistry. These early scientists weren't exactly looking to cure a headache or invent plastics. They were searching for the mythical philosopher's stone, literally trying to turn iron into gold, and the elixir of life to live forever. You can't blame them for dreaming big, but it wasn't exactly grounded in the rigorous scientific method we know today. And you're probably familiar with the standard historical timeline, right? It usually goes something like this. It starts in ancient times with Egyptian mummification procedures, which obviously required a deep understanding of preserving matter. Then, it moves to the 17th century when Arab scholars occupied Egypt, studied these practices, and named the science alchemia. Finally, modern chemistry as an empirical science truly takes shape in 18th century European laboratories. But let's execute a hard pivot here over to India, because while Europe was developing its alchemical traditions, ancient texts like the Vedas reveal a parallel, highly advanced tradition of practical chemical science. They actually had specific formal names for their chemical sciences: Rasayana Sastra, Rasatantra, Rasakriya, and Rasavidya. And this wasn't just mystical speculation for gold and immortality. This included the very practical, rigorous manufacture of cosmetics, glass, dyes, inks, and even medicine. Moving on to Section 2, Indus Valley chemical innovations, the earliest industrial chemistry. When you look at these sprawling Harappan ruins, we are definitely not just looking at basic mud huts. We're talking about remarkably advanced material science. Archaeological findings show us baked bricks and gypsum cement. And what is truly amazing here is that when modern scientists analyze the cement, it contains precise, deliberate traces of lime, sand, and calcium carbonate. They were intentionally mixing chemicals to create stronger, much more durable construction materials. So, what this means is that mass-produced glazed pottery, like this beautiful piece from Mohenjo-daro, isn't just art. It represents one of the world's earliest known implementations of a controlled chemical process. It shows a profound, foundational understanding of how materials change state under specific, meticulously controlled conditions. These ancients mastered a really precise sequence of steps. First, raw materials are carefully mixed. Second, they're molded into a desired shape. And third, they're subjected to fire to trigger a chemical change, achieving entirely new, durable qualities. They even applied this exact process to create something called faience, partially melted quartz used to make extremely strong, beautiful glazed ornaments. It's essentially early industrial chemistry happening thousands of years ago. Okay, Section 3, the first atomic theory, predating Western physics by millennia. Now, brace yourself for this one because there is an astonishing 2,500-year gap between the two figures we're looking at here. On the right, you have John Dalton, who famously presented the modern atomic theory in the 18th century. That was obviously a massive turning point for modern science. But over on the left, way back in 600 BCE, an Indian philosopher named Akaricha Kannada had actually already beaten him to the punch. He theorized that matter is made of indivisible building blocks. He called these microscopic particles anu, essentially describing the molecule, and even proposed even smaller aggregated units. And Kannada's theory wasn't just some vague, lucky guess. Just listen to the properties he assigned to these base atoms, which he called paramanu. He deduced they were eternal, indestructible, and spherical. He stated they were supersensible, meaning they're so incredibly small they absolutely cannot be sensed by human organs.
And perhaps most impressively, he accurately deduced that these unseen particles were in constant motion and could interact to form complex structures like pairs or triplets through unseen forces. Guys, this is theoretical physics happening in 600 BCE. It's mind-blown.
Which brings us to Section 4, Ancient Indian Nanomedicine, the Science of Bhasmas. Our source chapter highlights a pretty massive revelation, and I quote, Karaga Samhita describes the use of Bhasma of metals in treatment for ailments. It has been proved that the Bhasmas have nanoparticles of metals. Think about that for a second. This proves ancient Indian medical practitioners weren't just mixing standard herbs, they were actually utilizing early forms of nanomedicine by interacting with the human body at the molecular level. Now, as you can probably guess, creating these Bhasmas was a grueling, highly rigorous process. You can't just ingest raw metals. That's lethal. So ancient scientists would continuously burn and cool metals, minerals, or gems. Sometimes they'd repeat this highly controlled cycle over 100 times. Then they would mix the resulting substance with specific herbs. The whole goal was to completely break down highly toxic metals into safe, microscopic therapeutic particles. So the crucial takeaway here is that this absolutely wasn't ancient magic. It was targeted biochemistry. By converting drugs into a nanoform, practitioners drastically improved the drug's bioavailability. That simply means the body could actually absorb it while simultaneously wiping out its toxicity. It meant patients needed much smaller doses, the medicine acted way quicker, and the drugs themselves had a longer shelf life. Actually, it's the exact same principle modern pharmacologists use today to make treatments safer and more effective for all of us. Finally, Section 5. Ancient Wisdom, Modern Science, the Legacy of Indian Metallurgy. Just consider the famous Iron Pillar of Delhi. This isn't just a cool historic monument, it is a profound scientific anomaly. Erected centuries ago, it has miraculously not rusted, despite endless years of exposure to the incredibly moist, harsh air of the region. The metallurgical mastery required to forge iron with such immense, anti-corrosive properties is something that modern material scientists continue to study and honestly just marvel at to this very day. Which brings us to a final, pretty provocative question. If the ancients mastered early nanotechnology, perfectly balanced chemical construction materials, and fundamentally understood atomic theory thousands of years ago, what other lost sciences are just waiting in our history? It really makes you wonder how much of our global scientific heritage remains hidden in plain sight, just waiting to be rediscovered, understood, and perhaps even utilized in our modern world. Thank you so much for joining me on this explainer, and keep questioning the history of how we know what we know.